All right, so today we're going to do polynomial identities. This is going to help you in the sense that there are some rules with multiplying going forwards or factoring going backwards that you can see patterns and just follow a rule to do it quickly. Now, of course, with going forwards with multiplication, you can always go and do your box method, factor, whatever you need, or FOIL method, whatever you need, but it might take a little bit longer depending on what it is. So today's lesson and the next lesson are going to involve trying to do some of these things fairly quickly to be able to move ahead faster. Okay, so with polynomial identities, what we're going to do with special patterns are we're looking at like squares and cubes. So let's remember our perfect squares and our perfect cubes. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 36, let's see, 49, 64, 81, 100, 11 squared is 121, 144, is that 169? Let's see, 13, 13, 9, 3, 3, 1. Yep, 169. 1 cubed is 1, 2 cubed is 8. This is why in the past I've been able to do things like this because I know my perfect squares and my perfect cubes. 3 cubed is 27. 4 cubed, let's see, is 64. 5 cubed is 125. 6 cubed, let's see, 36 times 6, 6, 18, 19, 21, 216, and then 7 cubed is 343. I did this earlier today, so I know that. Okay, so what's going on here? So these are identities or rules that you can memorize to go forwards or backwards. So the way I like to think about this is when you're multiplying, you're starting on the format of the left side and you're going to the right. When factoring, you're actually looking at the right side and going backwards to the left. So here are our perfect square trinomials. So we're squaring the a plus b or the a minus b. And here's our cubic. So we're cubing the a plus b or the a minus b. Here, this should look familiar. This is the difference of squares. This is the sum of squares. So remember those of you in the past when I said with factoring, if it was like x squared plus 9, and many of you wanted to do the difference of squares, you couldn't do it because it was an addition sign instead of subtraction. Well, for those of you who connected with imaginary numbers last year, this is our sum of squares. It becomes imaginary right there. Then we have sum of cubes and difference of cubes. So we're going to look at these patterns and see how they help us move faster. So if you recognize the pattern, and that's the idea, if you recognize it, if you can't recognize it, it doesn't help you. So we're going to get familiar with it. And hopefully if you go to calculus or any upper level math, you'll be able to recognize these better. So first step is you want to figure out which identity you're going to use. Then you want to identify your A and B. Now substitute. Many of you are going to be able to figure this out from a pattern, and then simplify. Okay, so what we want to make sure you're doing is when you pick out what identity to use, that you are also figuring out, hey, am I multiplying or am I factoring? Okay. So number 1, we're going to multiply the expressions. So if you look at your identities, and I have a second sheet right here, so I'm able to look back and forth, and I compare, well, this is a perfect square trinomial. So I'm going to look at this a plus b squared, and then we're going to change it to a squared plus 2ab plus b squared. Okay. So in this case, our a is 4x and our b is 3y. After we identify our a and b, now we're going to substitute in. So I'm going to put them right under. So this is 4x. That whole thing is squared plus 2 times a, which is 4x, times 3y, which is b, plus our b squared, which is 3y. Okay, that's me substituting in. Now I'm going to simplify. 4x squared is 16x squared plus, let's see, 4 times 2 is 8. 8 times 3 is 24. So 24xy plus 3y squared here is 9y squared. And we were able to do that by using the polynomial identity instead of just doing 4x plus 3y times 4x plus 3y. Excuse me. Now, in the next one here, we're multiplying. Again, we're going to do this by identity. So let's look at this. This is the difference of squares right there. So the difference of squares tells me if I have an a plus b times an a minus b, then it is a squared minus b squared. Okay, let's identify our a and our b. Our a is 2a, or 2x, sorry. B is 5y. Let's substitute in. So this is 2x squared minus 5y squared, which then gives us, simplify this out, 4x squared minus 25y squared. Done. All right, so let's do this again. I have a 4x minus 5 cubes. So if I look at that, I can do the difference of cubes right there. Nope, it's not the difference of cubes. Incorrect. Remember, it looks like this. So it's right here. It's just our cubic. So this is why identifying the polynomial is very important, because you might just substitute into the wrong one. So we have this a minus b cubed, and that gives me, sorry guys, I got interrupted. Okay, so we're back. We said it's a cubic polynomial right there. So let me make sure I'm writing this down correctly. So it's a cubed minus 3a squared b plus 3a b squared minus b cubed. Okay, now be careful. I'm going to put this right under here. So a equals 4x and b in this case. Now remember that subtraction's already there. So b is just 5. Now I'm going to substitute in. So I have 4x cubed minus 3 times 4x squared times b, which is 5. Okay, now we're at this plus 3 times a, which is 4x, times b squared, which is 5, and then squared, minus b cubed, so 5 cubed. I'm running out of room, aren't I? Okay, so 4 cubed, that was 64x cubed, minus, let's see, let's do it this way. Oh, this is 16. Gosh, I need my calculator now. So let me just do this on the side. I don't have my calculator with me. So 16 times 3, 18, 1, 48. 48 times 5 is 4, 24. So 240. Did you guys get 240? So this is 240x squared plus, let's see, this is 25. 25 times 4 is 100 times 3, which is 300. Now, don't forget, guys, this is just x to the first because only that 5 was squared, not x. And then I know that 5 cubed is 125. And there is our answer. Now, again, could this have been faster using your box? Maybe. But they start to have multiple ways that you can get through things. Okay, now D here. I'm going to look at this. I have an A minus B. So here is our difference of cubes. Okay, so this is A minus B. And then I know that this is the rest of the polynomial. But what I want to show you is with this rule is really all I need is that A and B. Okay, so A equals 3x, B equals 2. Now, according to the identity, right, it was A cubed minus B cubed. So when I substitute in, I get 3x cubed minus 2 squared. Why did I say squared? It should be cubed. Did anyone catch that? All right, so when I simplify it, 3x cubed would be 27x cubed, and 2x cubed is 8. And we're done. That one was probably a little bit faster if we memorize that to a T. Now this, as you can see, do we have a rule here? No, because if this were A, this would be A. Let's say this is A minus B. Is this a B? No, it's like a C. So unfortunately, this one doesn't have a rule. We have to FOIL or do our box. Now, all in all, this comes out to x squared. That would be plus 3x minus 10. I can do that fast because I've been factoring forever and multiplying forever. Okay, so this one you'll have to do like your normal style of your box or FOIL because there's no exact identity for you to follow, unlike the ones above. Okay, let's go backwards. Now remember, when we're identifying the polynomial identity, you want to make sure you're looking at the right side first. So we're looking at something like an A plus B. A plus B. So we on the right side here. So right here, no A plus B, no A plus B, A plus B right here. You guys see that? Now here is an A plus B also, but this tells me it's going to be this top one because we're talking about square. Okay, so we're looking at this A squared plus B squared, and we're going to A plus BI times A minus BI. Okay, I found my identity that I'm going to use. Now I want to describe my A and B. Now this is A squared. So what I'm going to do is take the square root of this to find out my A. My A comes out to be 2x, and my B comes out to be 9, not 9, 3. There we go. And now I'm able to substitute in, and I have 2x plus 3 times 2x. I got my I there. Minus 3i. Done. Oh, there you guys go. All right, for B here, I have an A plus B. Now remember it's cubic, so A plus B. Again, I'm factoring, so I'm going to look at the right side. Nope. There's an A cubed plus B cubed right there. So A cubed plus B cubed. And what we should end up at the very end is A plus B times E squared minus AB plus B squared. This is our identity. Let's talk about our A's and our B's. Now, to get our A and to get our B, remember last time we took the square root. So what we're going to do now is take the cube root of both of these to find our A and our B. So this would be 3x and this would be 4. Now I'm going to substitute in. So A plus B, and then times, and do you guys mind? I'm going to do some multiplication right away here. This is A squared. So 3x squared is 9x squared minus 8 times B. Like 3x times 4 is 12x plus B squared. Well, 4 squared is 16. We're done. Okay. Remember, we're factoring. Let's look at the right side. So I have this sort of A minus something B, right? Something like this. And I have a trinomial here. As you can see, these are all binomials or 2 terms, right? So I can't think of the 3 terms. Well, here we have 4 terms, so it must be up here. Now, the other thing I want you to notice is that this goes positive, negative, positive. So positive, negative, positive would be this one right here. So we have A squared minus 2AB plus B squared, right? And that should end up as A minus B squared, right? According to the identity right there. This is what I have. This is what I should get. So really what I just need is that A and B. And again, this is A squared, this is B squared. So how do I get A? I take the square root of that number. So this would be 3x. And the square root of that B term, or that last term right there, the square root would be 2y. So when I substitute that in, I end up with 3x minus 2y squared. Now, could we FOIL? Yeah, well, not FOIL. Factor A times C, all of that stuff we could, but then it gets more complicated as we go. So I'm going to see if there's patterns. Okay, first, remember, we're looking at the right side. So I'm looking for 4 terms. And as you can see, the signs go back and forth. So right here, the 4 terms going back and forth is right here. So this is in the form A cubed minus 3A squared B plus 3AB squared minus B cubed. And our resulting should be A minus B cubed. Right there. So all I care about is the A and the B, it looks like, for my answer. Where can I get that A? From right here, and that B, right? Cute. So how can I get A? I have to take the cube root. So what's the cube root of 8x squared? That would be 2x. What is the cube root of 125? Well, that would be 5. So substitute in, we get 2x minus 5 cubed. And we just factored 4 terms into a cubic. All right, E. Okay, so let's look at this one. It's 3 terms. But as you can see, remember before when we were dealing with our three terms, we cared about our a and our b. And our a would be x, but can we take the square root of 6? No, we need perfect squares for this. So this one, guys, you're just doing your box or your grouping method of factoring. So when you're done with this, this should be x. Let's see, we're gonna do plus 3 times x plus 2. And we're done. Again, do it by your box method or your grouping based on our first chapter. So now let's do some practice. Let's see if you can memorize some of those identities.